So, hey everyone, my name is Filip. I work here in Prusa as a DevOps engineer. And last year, we went to KubeCon in Paris, and we saw there a talk, interesting talk by Acuity, who is, they are a creator of Argo, and this presentation is based on the talk. So I will introduce an approach that really resonated with us, and we decided to use it in our work. And we believe that it is a solid strategy that deserves your attention. When you look at opengitops.dev to check some GitOps principles, you will see that it's all about desired state, how you declare it, how you version it, and how you apply it. So what is a desired state for Kubernetes? How you declare it? Well, I guess a lot of you is now thinking about Helm or Kustomize, because that's how you define your applications. But are they really the desired state? Let's take a closer look at that. Helm and Kustomize, or Kustomize, I have the Czech pronunciation, are popular config management tools. And those tools are then abstractions over plain manifests and allow you to define some common set of manifests and adapt them for different environments. We like them because it's dry and help us to they help us to keep manifests concise and manageable. Those abstractions, your repositories with Helm or Kustomize, they are typically referenced directly by GitOps controller like Argo CD or Flux. Let me say from now just Argo, and you can substitute any GitOps controller you wish. But I use Argo, so I'm kind of like, that's the first thing that comes to my mouth. OK, so Argo integrate Helm and Kustomize. It is watching your repository where you have those abstractions, Helm and Kustomize, Helm or Kustomize, and it basically does Helm template or customized build to create the final manifest on the fly. And then it deploys it against Kubernetes API. This is what we will call runtime rendering. And we will discuss some problems it can bring. I will mention 3 of them. First is obfuscation, toolchain dependencies, and performance. When we are all dry with Helm or Kustomize, we sacrifice visibility to what is actually deployed. For example, here you can see, or not, bump of a subchart in my repository. And when I will approve a merge request like this, this is really the only thing I will see. And of course, I can examine the chart. I can try to render the manifest locally, maybe even take into account some options that I have specified on application or on Argo CD application. I mean, like options for the Helm. But yeah, good luck with that. So personally, I every time end up disabling autosync, examining the difference, the diff in Argo, and then syncing. Then I enable the autosync again, and I think this is a kind of anti-pattern, you know? Even for like minor version updates of a chart that you consume, but you don't maintain, you have to like rely on the somewhere being correct, or you have to check somehow what is changing. Here I have specified some values And for this very simple usage, you are maybe too lazy to give it a proper check, and you just deploy it to dev, and everything is fine. Then you deploy it to stage, everything fine, but then on prod it's not that good at all. Because what happened? You realized that the master block was renamed to primary block, and that you basically removed resources from your cache. And it is like, yeah, the cache won't be very happy. I won't say this didn't happen to us, because it did. Okay, second problem, toolchain dependencies. As I said before, Helm and Kustomize is included in Argo. And all the manifests are rendered by Argo uses those dependencies. So then, when you update Argo, can you be 100% sure nothing will change in the manifests that are rendered by Argo, by it? I think I don't have to say anything more. Third problem is performance. Rendering manifests can consume significant resources. They are rendered when there is a change in the source, when manifest cache expires, by default it's every 24 hours, or when some user requests a hard refresh of his application. I don't have first-hand experience with this, but in the original presentation, Nicolas from Acuity mentioned that some of their customers had a node with 200 gigs RAM just for the repo server. So it can be quite expensive. So what can we do with all this? Let's try to solve it by reconsidering what do we mean by desired state. Desired state is the rendered output, but not the abstraction. And we should store it. We should render it and store it in Git. So we render the manifest in CI and store it in environment branches. You can see it on this picture, where I have main branch containing my abstraction, my Helm or Kustomize, and then CI running Helm or Kustomize, or anything like that will render your manifest and putting them to branches. Argo will just, or any GitOps controller, will just take the plain manifests and apply them directly to Kubernetes without any tooling between the desired state in Git and the reconciliation of the actual state. This approach treats your manifests as artifacts, just like container images. In contrast with runtime rendering mentioned before, that is like running apt-get install every time you start a container. Well, we don't do that. We build immutable images. So why should we build manifests at deploy time? By the way, this approach also allows you applying some policies like requiring merge requests, protected branches, or approvals, and so such stuff that is very useful. And no, it is not Git flow, because the branches are orphaned, never merged, maintained automatically, and not used for promoting my environments. We still work just on main. Well, and that's basically it. Now let's take a look at how we implement this pattern at Prusa. Firstly, we use GitLab. We have application repo for we have application repo which in its CI builds the image and triggers update with the new image tag in manifest repo. For each application repo, there is a manifest repo. And in this pipeline, in manifest repo, the image is updated in main branch, and then new manifests are rendered. And finally, the manifests desired to be deployed to stage cluster are pushed directly to stage branch, and manifests desired to be deployed to prod are deployed to another branch for which a merge request is created to prod. And then there is Argo watching our stage and prod branches, deploying everything that's in it. Yeah. This is just some pipeline. This is our pipeline doing all the magic. It's basically a few rather simple GitLab CI components that will update the image, render the manifests, and push them to desired branches. You can use this. You can do like us some in-house solution, or you can take a look at Cargo Render, which is a sub-project of Cargo, and it does basically the same thing. As I said, we have manifests, manifest repository with environment branches and rendered manifest in those branches for each application. So now, how we deploy those applications? The core of our deployment lies in the core repository. It contains some Helm templates plus values defining some app projects, Argo CD airbag, and Kubernetes airbag, but mainly it contains application sets which deploy the manifest from those manifest repositories. And for each application set, it also contains a next prefix application set for DevOps resources. Basically, those are resources like network policies, resource quotas, external secret stores, and namespaces, and other cluster resources that we don't want the developers to be creating. And all those templates are then rendered and pushed to the environment branches, stage and prod. And as you may notice, maybe not, there are also core applications which are just Argo CD applications referring those two branches in our core repository. So to start to to kick it off, you just deploy the core prod application, and everything gets spin up automatically. Yeah, this is a snippet from the values in the core repository, where you can see how we describe application sets for teams, and yeah, you can see that there is a GitLab group where the application set can find the repositories with manifest. Also, there is a flag that if it should create the Argo CD project, but important part is that there is a list of applications, and also, as you can see here, some anchor like placing there members of the team. Based on this list, we will create the airbag to Argo and to Kubernetes resources. And for other teams, it looks similar. Well, I think I have time to show you. Some repository. No. Okay, not sure what's going on. To je krása, co? now we go. This is an example application where I have already built some image, and we can see that there was this pipeline building the image. Well, it was stage build, and then triggering update in another repository, which is the, I will do it here, which is the manifest repository. And here, it was this pipeline pushing to main the change of the image, and then rendering the manifest and pushing them to stage branch to the deployment resources. Now I can, maybe I can show you that if I create a new tag, maybe v11, there should be a new pipeline tagging the image and pushing to the manifest repository this change that should create a merge request to our prod branch. We will see how this will go. Where can I find it? Build. Yes. Something's going on. Adding the tag. Oh, now we wait.
May I ask?
Yeah, sure.
The wait time. The pre-rendering of the manifest, it's part of the application repo, not the cluster or something like this repo.
It's part of the repo with the manifests.
Yeah, of the application.
Oh yes,
yeah.
Yes. There is this repository is a repository of the application code, and this other one, where I just triggered the pipeline, is repository containing Helm chart or anything that you use. And here, now, I have a new pipeline that will push the v010 tag into the main branch, then render the manifests with this tag and push them to some branch which will be merge requested to the prod branch. Sure.
And you have...
Yeah, so we can hear it in the stream.
A question during
one question that, if I understand that correctly, every application have application repository with code and manifest repository for every application separate repository.
Yes.
That you have, for example, 100 application, you will have another 100 repositories with that. Okay. And one other thing, do you think thinking about replacing that rendering manifest and pushing them to the OCI repository is the same as Docker images?
I think it is the future. But I'm not sure if for us, but I think like the
we're using Influx
OCI will
already
be,
for that, but I don't know if Argo supported that.
Yeah, it is. It does.
It is.
Yeah,
it does. Okay. Okay.
So maybe I will already have. Yeah, those names of merge requests are a thing that we have to deal with yet, because it should be called v1 and not the previous commit. But we can see the change that is going to happen. We can do anything we want. You can comment. We can argue about it, and then finally you can merge it. And now back to the presentation. Maybe I want to see it also here. How can I take it here? Yeah, it's F11. Yes. Okay. This was just to show you how we do it, but now let's get back to the main thing with a short summary. The presented approach is basically about that you should not modify the source of truth just before it gets applied. That's why we consider desired state, or we consider rendered manifest to be the desired state. We render those manifests in CI, and we store them in environment branches. And they serve for us as the source of truth. Here are some benefits of this approach. It eliminates obfuscation, reduces toolchain risk, reduces load to GitOps controller, and allows defining policies like merge requests and run project protection. And also, there are some cons. As you probably realized, the work moved from GitOps controller to the CI, so we have more complex pipelines. And also, you lose some built-in features of Argo CD or your GitOps tools like Helm hooks or some runtime value injection. So there are some cons. That's about it. Here are some resources, including the original talk. Thank you for your attention, and I'm ready for some questions. Slido.
Give a second. So, first question. So, any plans to open source this?
Well, I think Cargo Render is the is the open source version. If you use GitLab, it already has GitLab actions for rendering and pushing to environment branches. It's quite simple tool, and it is very useful.
Maybe it's important to say that we did it before the Cargo was released, because the Cargo,
This was very early stages. Yes.
Yeah. Because Cargo last year wasn't useful. So yeah, but this year, especially at this KubeCon, a month ago, so we saw that the Cargo is pretty in a production state. So I can recommend it to look at it.
How long it took to implement all of this magic? Well, it was, I guess, in July last year when I decided to try it, and it was like maybe 2 weeks of the proof of concept, and then we started to put it to some small applications, incrementally improving the components. But yeah, it's not that complicated, so it wasn't like taking too much time.
But you should mention that migrating
all
projects.
The migration is the problematic part. Yes.
But just the implementation of this thing, it's not so big. So
Yeah. How about Helm charts, which are quite stable, so can be left alone to be auto-upgraded by not specifying chart version? Third-party mon agent. Okay. I'm not really sure. For this, you will have to somehow automatically run the pipeline to render it with the new version. If you have some dependable or something pushing in your repository, then it will render the new manifest. And I think we would just skip the merge request part of pushing those manifests to prod, and it will push it there, I guess, if you're brave enough. If I understand the question.
Sorry, it's my question. Maybe I'll.
Give me a second.
I'm talking about not application for business, I would say, more for infrastructure. So there are Helm charts which are parts of Kubernetes. For example, monitoring stack. I know some Alloy agents, some Grafana agent, something like is not is third party for you, and you probably should deploy it to cluster, and it done with the same flow as application. So everything is rendered, all the Helm charts.
Well, for us, we don't have it like this, but it would be nice because it would be easier to track the changes when you update, for example, Prometheus chart. Then you will actually immediately see what's going to change. You will just scroll through the merge request and see, okay, this is not this is just version numbers, and there is for some small change. This is okay for me. I can update. But when you do it like, I don't know, we have some Helm charts deployed by Terraform, and it's quite pain to like see what's going to happen. You know, you like try to guess what could go wrong, but when you are sure nothing will go wrong, something will, for sure.
Yeah.
So I would use this approach also for deploying those. But yeah, as you
Okay.
it depends.
I can just add that I'd like to see some, stable Helm chart. You can show it to me, some of them. So next question.
How about using similar approach at cluster level repository, repo representing cluster composition of components, or is it used just for developer managed apps? Well, for now, most of usage is for developer managed apps. Cluster composition of components.
If you are not sure, so we can ask if there is the guy who,
That was my question.
Okay.
Can you like?
If you build a cluster and you composite it as as many components you put together into the cluster and make the thing work together.
Like you mean things running in the cluster?
Yeah. I mean ingresses and
Yes.
secret managers and these components. But how are you managing this part? It's completely different, or do you use some similar approach, like using for secret manager using Helm, but rendering it before it goes to Argo or other tool?
No, for now we have a lot of components that are deployed using Terraform, and I think every time you have to draw the line somewhere. You can't, for example, deploy Argo using like this. You have to first put it there somehow. But I think it like ultimately it can be used for a lot of things, but not for. I wouldn't use it for like spin up of the cluster itself.
Thank you.
I can imagine that it can also be used for the spin up the cluster and also the basic components, but you should use some components like crossplane for the spin up part, and then the crossplane can be applied in this approach. But it's not so common. It's more common that you will spin up the cluster itself via some infrastructure as a tool like Terraform, for example. And then you can spin up some basic tools, like we can call it DevOps tools, like the Argo CD monitoring and secret management and stuff like that. Also via Terraform or via Crossplane. It's not so common to use this approach for that.
For example, we are using this approach Terraform install the cluster, install Flux, and everything else is automatically installed by Flux. And that different approach is that we don't use Git. We use OCI repositories for Docker images and configuration of manifest. That's everything is have rights to access. Yeah? If we use GitHub or GitLab, we have that issue that we need secrets and other things, and that will be more complicated. But if you put everything in OCI repository compatible, you cluster already have access for downloading images, and this can be set up quite easily. I think it doesn't matter if Argo.
Yes, yes. What GitOps controller you use is really up to you, and it doesn't make any big change or difference.
Or if you can manage Kubernetes from Kubernetes, you can also think about vCluster, for example. I hope that everybody knows about it. It's just amazing tool managing Kubernetes in Kubernetes. So you should look at it. It's also another sincere project. So I think it was answered, so we can move on.
How do you manage secrets and their injection? Well, we have secrets stored in Vault, and we have an external secret component, which is there is interesting part to that. We have in the core repository, when you deploy an application, then the part of the X application is a cross-plane resource that will create the permissions for the external secret to touch just the part of Vault that belongs to the application. So yeah, this is how we do it. Yeah. I think that's it.
Yeah,
we can move on.
We can move on.
Nothing is stable enough. You don't want your Helm chart to auto-update. It's just a comment for the previous question, I guess.
We'll see.
Yeah.
No, it's also interesting that the Argo and, for example, Flux are making different job with rendering the manifest. Yeah? Because, for example, the Flux are using the standard Helm, to render the manifest, but the Argo CD is just using their own way how to manage it. And there is one more disadvantage, and is it that if you change the version of the Helm, for example, so it can render it and manifest in different manner. So if there will be, for example, a change of the Argo CD version, so it can cause some issues. It happens in past. So it's one of the advantages why you can use this rendered manifest, because you are sure that it will be all the time the same. So that's it for my side.
The next question: have you ever hit some performance issues with Argo at Prusa? Well, the short answer, no, because we have we have like 100, 200 of applications running, so it's not that big scope to hit really some issues. Or I don't remember if you remember.
Yeah, I can share something. We hit the performance issue with the Argo. It was, I think, 2 years ago, because we are one of the first implementers in Czech Republic for the production of the Argo. And there was some issues in past, but right now there's no issues. But yeah, of course, you can read some articles about when there's a lot of applications, there's the issues with the performance, and when you check the documentation of the Argo, there is the recommendation that you shouldn't use just one Argo instance for running all the application. There is just three structure how you should set it up. But of course, it will be changed with Cargo.
I think there is interesting talk called something like 10,000 sync applications by one click or something like that, where they really stretch the Argo to its best.
It was one of the talk I think on last year KubeCon. So it was very interesting. That there is some limit, but I think that most of the companies didn't reach it, because it's a very huge number. So we can move on.
Considered to manage Terraform with Argo CD /crossplane? Well, we have. I haven't tried it was Pavel who tried it. Maybe he has something to say about it. I think he was not that thrilled. Not sure. How you enjoyed trying to manage Terraform using Argo? Yes.
I think it's not the best idea. We can talk about it during the networking part, but I don't want to share it here, on the record. So.
What do you think is better, your solution or Cargo? I would say, of course, it's our solution. No, I don't see it into Cargo that much. And when we decided to go this way, the only thing that we checked is like, are we giving up on Cargo with this? And the answer was that we are not. It wouldn't be that hard to go to it, but maybe for us it's too like maybe overkill, I would say, or like
If you think about the Cargo and just for the rendered manifest, I think it's not the right way, because the Cargo is pretty good, but it has pretty much different additional value. Like for example, if you wanted to have some more complex pipeline, with some stages, so it will be hard for you to implement it via Argo CD. Maybe you can make some triggers or stuff like that. But if you wanted to run it with the Cargo, there are some phases. It's pretty easy to implement it. So yeah, you can still use it via Argo, not Argo CD, with Argo Stack, because there are some Argo routes, Argo workflow, and also Argo events. And you can combine it, and then when you combine for these components, it's the Cargo.
We're talking Cargo render, not Cargo.
Yeah, sure. If we speak just about the Cargo tool, not Cargo render it thing. So the question was about Cargo. So yeah, but of course, if you just compare it with the Cargo render it, so I think it's very similar. So. Is there any question in the audience here? No question? So if not,
I think I had enough.
Okay, it was enough. It's short. So thank you, Filip.
Yeah, thank you for your attention.